I'm Paul Epps. We're doing Leetcode must-know interview questions. Today's challenge, jump game. We're given an array, an integer array, nums, initially positioned at the array's first index, and each element in the array represents your maximum jump length at that position. Return true if you can reach the last index or false otherwise. Okay, these examples are a little bit too simple probably, but the idea is you start at the first element. From the first element in example 1, you can jump two spaces, max, meaning you could jump to the 3 or you could jump to the 1. Well, if you jump to the 3, then you can jump 3 more to the last element, and you're done. Leetcode rates this as medium difficulty. To me, this is a hard problem. The things that the things that occur to you as far as solving it are probably not going to work. You can do a recursive solution. For example, if the problem is can we jump from the first element to the last element, we could reduce that problem to can we jump to the last element from any of the elements we can jump to from the first element. So from the first element, we could jump to the 3. We could jump to the 1. Can we jump to the last element from either of those? And to do it the least efficient way, let's say we jump to 1. Now, can we jump from 1 to 4? Well, we could reduce that to can we jump to the 4 from wherever we can jump from the 1, which is here. Now, once we get here, it's solved. But the problem, well, let's look at the constraints here. The constraints length, okay, 10 to the 4th. So what is that? 4 zeros, 10,000. So the array can be up to 10,000 elements. You can do that recursively. I just don't think that's going to run fast enough. Under topics, they list dynamic programming. You could do a dynamic programming solution. That's also good. I mean, that's going to be O of n squared. And what is 10,000 squared? So now we got 8 zeros. So that's 1 to the 100 million. Is that 8 zeros? Oh, it is. Okay, so yeah. I mean, that's going to be tough. I usually ballpark these things at like about 1 million operations a second. And so 100 million is a lot. But dynamic programming, yeah, you could build up an array of the same length, well, actually the same length plus 1 as the given array, and then build up the solution using dynamic programming. Can we get to the second element? Can we get to the third element? Can we get to the fourth element? And so on. I think I said it's still, you're going to need a nested loop. It's O of n squared. So is there some way we can do this with one pass through the array? Okay, let's see. Nums length minus 1. Okay, yeah, so usually when I do these, I kind of sketch out the algorithm and then code it, and I'm not sure if I can explain it very well if I do it that way. I'm not sure if I can explain it very well if I do it this way either, but I'm going to try and write and code at the same time. So let's look at what this program is going to do. First of all, if nums length equals 1, then we're just going to return true because the first element really is the last element. So we're done. Return true. If the first element of nums is greater than or equal to nums length minus 1, we're just going to return true because we can jump from the first element to the last element. If the first element is 0, and we already know that the length of the array is longer than 1. If it wasn't, we would have returned true on line 4. So we have an array that's longer than 1, and the first element is 0. So we're stuck. We can't get out of there. So in that case, we're going to return false. All right, some variables that we're going to keep track of. Max reach and step. So max reach is the maximum index that we know that we can reach. We initialize it to nums 0, which is 1. So I can put that over here. 1. It's kind of sloppy, but that's a 1. Step. Okay, step is the number of elements that we can reach from the element that we're currently on. Essentially, it's just the contents of the element. So that is also going to be initialized to the first element, which is 1. All right. Now we're going to drop into the loop. We're going to loop through the array. We're going to start out with I equals 1. Okay. Each time through the loop, we're going to do a couple of checks. We're going to check and see if I equals nums length minus 1. Because if it does, we are done. We'll return true. We got to the end of the array. Next thing we'll check is if nums at index I is greater than or equal to nums length minus 1 minus I, meaning that nums at index I is big enough that we can just jump to the last element. So we'll return true. Next thing we do is check the max reach. All right, so we start at index I equals 1. And we set max reach to the max of whatever it already is, or I plus nums at index I. So I is 1. Nums at index I is 3, right here. 1 plus 3 is 4. So we're going to change max reach. I'm just going to kind of redraw it here. So it is now 4. So we know now that we can get to 0, 1, 2, 3, 4. Yeah, we can get to index 4 because we can jump 3. Index 9 is at index 4. So we know that we can get that far. All right. Next, we decrement the step like this. And what that means is that we have no place else to go. From the first element, which is a 1, there's only one place that we could go, and that was to element 3. So step becomes 0. All right. We got to check for step equals 0, because if step equals 0, that means we got to jump. We're out of options. All right. So, well, actually, you know what? We don't really have to do that. We don't have to track that at all. I'm going to take that out. If step equals 0, what do we have to do? We got to check for I. We got to check for I if I is greater than or equal to max reach. Then we have a problem because we have gotten we've gotten our index in a place that we really can't get to, and so there's no way to proceed from here. So return false. Let me indent that. All right, and also let's update step. So step is now going to be equal to max reach minus I. What is max reach? Max reach is 4. I is 1. So we're going to update step to 4 minus 1. It's 3. What that means is from the element that we're currently on, which is index 1, we have 3 places that we can go. We have 3 steps that we could possibly take. We could go to 5, we could go to 8, we could go to 9. All right, back up to the top of the loop. All right, at the top of the loop, I is going to go to 2. I some length and true. Now we're not done yet. So those 2 if statements, we can bypass those, but we've got to update match reach. All right, match reach equals max of match reach, which is currently 4, or I plus nums I. I is 2, and nums at I is 5. So max reach just went up. Max reach, we know that we can at least get to index 7. Because from index 2, we can jump 5. All right, we've got to decrement the step. There are only 2 more options we can explore. So the step is now 2 if step equals 0, and it doesn't. All right, back to the top. Increment I. Let's see, if I was nums length, if nums I is right here. If nums I is greater than or equal to nums length minus 1 minus I, what is the length of that array? 11. Minus 1 is 10, minus 3 is 7. So actually nums I is greater than, so from the 8, we could jump to the 9, right? 1, 2, 3, 4, 5, 6, 7. Yeah, we could. So this is going to return true. All right, that's it. Let's run it and see what happens. I'm going to take this whiteboard down for now and run. Whoops. That needs a semicolon. You know what? Yeah, I can do this so I can see what's going on. Run. Pile error, missing return statement. Oh, right. If we get all the way through this and we haven't returned true, that if we haven't reached the end of the array, then we need to follow my brackets here. Okay, so that is the end of, okay, so it's right here. We got to return false. If we get all the way down there, we're going to return false. Run it. Okay, accepted, submit. I don't think there's going to be a problem with time on this. It's just a question of whether or not it works. Okay. So that's accepted. I don't know if I can fit all this on the screen at once. But yeah, so that's an O of N solution. Leetcode said that's a medium problem. I think that's a hard problem. And that's it. Feel free to subscribe, like, and see you next time.